Sacc1026 helps the rumen run the way nature intended, despite changes in ruminant diets over the years. The metabolic activity of the yeast cell in Sacc1026 serves to modify the rumen environment and increase the quantity of nutrients available to the cow for milk and meat production. When Sacc1026 is added to the diet, the net result is more energy from the same ration. Live, metabolically active yeast cells, specifically strain 1026, have a tendency to consume oxygen and sugar in the rumen. This sugar consumption limits the food available to lactic acid-producing bacteria, preventing them from converting sugars to lactic acid, therefore maintaining rumen pH. The yeast cell also takes up oxygen in the rumen, helping to maintain anaerobic conditions and modifying the rumen environment in favor of fiber-digesting bacteria, activity, and reproduction. The rumen is a hostile environment for yeast cells. When metabolically active yeast cells are placed under stress, they begin to secrete small peptides. Both fiber-digesting and lactic acid-utilizing bacteria consume these peptides, which stimulates their activity. Stimulating lactic acid-utilizing bacteria accelerates the consumption of acid and stabilizes rumen pH. With a more stable rumen pH, fiber-digesting bacteria do not go into a temporary dormant stage, and fiber digestion is more consistent. Simply feeding peptides to the bacteria present in the rumen will not dramatically increase their populations. Sacc1026 has a significant impact on the number of microbial bacteria because the metabolic activity of the yeast cell creates environmental changes in the rumen. Research on strain 1026 has shown a 10 to 15-fold increase in beneficial rumen bacteria populations when Sacc1026 is added to the diet. This in turn has a positive effect on rumen efficiency, as well as driving dry matter intake and milk and meat production.